Hi, welcome to my channel, Crazy Code Dunia. In last video, we seen almost 10 question on Java. Here, we are trying to cover almost next 10 question in this video. Basically, we are targeting basic question first, and then we are increase the modularity of that question, like simple, moderate, and then experience level question must ask. So, in this video, we are covering almost 10 question. So, which are very important question like what are the data types, what is the JVM architecture, what is GIT, then internal structure of JIT, what is class loader, then internal structure of JVM. So all the important question we are taking in this video. Please watch continue. If you like this video, please like and subscribe. Okay, so let's focus on today's first question, that is explain the different type of primitive data types and describe each by size. This question may be asked in fresher level. So what are the different data type in Java? What are the different data type in Java? So there are 8 different data type, as we seen in yesterday's video also. There are 8 data type called as boolean, byte, character, short, integer, long, float, and double. So how question will be framed? So the question will be directly asking what are the different data type in the Java or size of that data type. So let's check what is the size of each data type. So let's consider boolean. The size of boolean data type, there is size of boolean is 1 bit, and default default value of boolean is false. Default value of boolean is false. Okay, this thing we need to understand. What is the default value of boolean? Default value of boolean is false, and size of boolean is 1 bit. Second, what is size of byte? So byte size is 8 bit and default value is 0. Default value is 0. Third is character. So it is Unicode character. So size is 16 bit. Size is 16 bit. Just look on the screen. Size is 16 bit. It is used to represent ASCII character from 0 to 225. Okay. Then short. Short is a data type which is rarely used in Java. So size of short is 16 bit. Size of short is 16 bit. Default value of short is 0. Default value of short is 0. Then most commonly used data type in Java is integer. Most commonly used primitive data type is integer called as int. The default value of int is 32 bit. Is 32 bit. Then long. Long is to represent the long value like mobile number or more than value like uh, range of light, travel from sun to earth. So that kind of value if you want to store, then we are using long variable. So long variable having size is 64 bit and default value is 0. Then float. So float is floating point. It is used for floating point. To check up to 7 decimal value, we are using float. So size of float is 32 bit. And then double. Double is check more accuracy like 60 decimal point till 60 decimal point we are using for double. So size of double is 64 bit and default value is 0 0.0. So these are the 8 primitive data type we are using in Java. So next question. What GIT compiler in Java? GIT compiler is a part of JVM. GIT compile bytecode to machine code at runtime. Means we have a GIT compiler in JVM. That compiler compile our code into machine code. Whatever the bytecode converted by JVM, that JVM converted bytecode, it will be convert into machine code at a runtime and improve the performance of Java application. Using of this one, we are say that our Java is high performance because of GIT compiler. So what is working of GIT? So working of GIT is simple. First, JVM will be convert our Java source code into bytecode, and that bytecode will be checked by GIT environment variable. If it is set, then it is passed to GIT. Or if it is not set, it is no, then it will go to interpreter of JVM, then OS of classes and libraries call, and then it will go into the hardware, which hardware that code will be using. So let's check the theory. A Java development kit JDK provides the Java compiler called Java C to compile the Java source code into Java bytecode. As I mentioned, JVM will be converted Java code into Java C or bytecode format. Okay, after JVM load .class file at a runtime and transport that bytecode into binary code by using JIT. By using JIT, we can transfer .class file to machine code or binary code by using JIT compiler. Further, that machine code used for interpreter. There are interpreter. Interpreter means we have an interpreter. Suppose I don't know language of Japanese. So if I want to communicate with the Japanese guy, there is an interpreter between converted our language to Japanese language and Japanese language to our Hindi language or English language. So we require interpreter. So same thing happen here. Our machine is not able to understand our high level language. So interpreter will be converted our high level language to machine level language by using interpreter. You know that interpretation of Java bytecode reduce the performance of native application. It is the reason implementation of JIT compiler. The JIT compiler accelerate the performance of application by compiling bytecode into native machine code. Means what here? While we are converting our Java code to level language code, that time we require more time. So the JIT is the compiler which is help us to accelerate the performance, and it will convert our Java code file or bytecode into machine native machine language code. So that's why JIT is used to improve our performance. It is enabled by default when method is invoke. It is enabled by default when machine is method is invoke. The JVM directly invoke by compile code and method without interpreting it. It does not require much memory usage. So these are the internal structure of JIT compiler. Okay, let's check. Explain architecture of JVM. This is most commonly used architecture or most commonly asked interview question to fresher as well as experience level. So what is mean by JVM architecture? So we have a in JVM architecture there are 8 different component. So let's check the component. One is class loader, second is method area, then heap memory, then JVM language stack, then PC register, native method stack, then native method library, then native method interface and execution of engine. So these are the component in JVM architecture. So what is the use of each component? So class loader, it will load .class file into JVM. So what is the use of class loader? Class loader, it will load .class file into JVM. Then once it load into JVM, it will come into method area. So method area, class code will be stored here. Means whatever the class we have created, like we have created demo dot class. So that class store into method area first. The class method area store per class structure such as runtime constant pool. Means whatever the class we have created, it will be stored in method area first. So in runtime constant pool, field method data and code for that method. So all the method or all the class will be stored in method area first. Then what is heap area? So we have a heap area. So object will be stored into heap area. What object will be stored in heap area? Then we have a stack. Then we have a stack. So method execution information will be stored in Java stack. Will be stored in Java stack. So stack store a frame. It hold local variable and partial result and play a part of method invocation and return. Each thread has a private JVM stack. Each thread has a private JVM stack created at the same time as a thread. Means we have different thread in Java. So each thread has different stack, and same a thread when it is created. A new frame is created each time a method is invoked. Means when method is invoked or when method will be called, that time each frame will be created and that each frame will be stored in a JVM stack. A frame is destroyed when method invocation complete. When that method is completed, then our whatever the frame we have created in the stack, it will be destroyed. So this is called as JVM stack in JVM architecture. Then we have a PC register. It will maintain next line information to execute. So which next line we have to execute, that is taken care by PC register. Then what is mean by native stack? It will maintain non-Java code execution information. It will maintain non-Java code execution information. Okay. And native interface, it will load native library into JVM. If suppose I want some other libraries instead of this one, like I want C libraries, I want C++ libraries, I want SQL libraries, so that all libraries will be stored into native stack. What is mean by native interface? So next part is native interface. Next component is native interface. It will load native libraries into JVM. What is the use of native interface? It will load native library into JVM. Native libraries, non-Java libraries, which are required for native code execution, which are stored into native libraries. And then last part is execution engine. It is responsible to execute the program and provide output or result. It will be interpreter and JIT for execution. Means it is execution engine is responsible to execute program and provide output to our interpreter and JIT for execution. So these are the JVM architecture internally, how JVM is work. These are the these are the component are used to perform our Java program. So each component has their different functionality. In this way, JVM architecture work. Let's focus on next question. What is class loader and how many type of class loader are in Java? I saw this question may be asked in fresher level as well as experience level, but most of the people don't know how many class loader are in Java. So let's discuss. Class loader is subsystem of JVM which is used to load a class file. As we seen in our JVM architecture, what class loader do? It is used to load class file. Whenever we run a Java program, it will load first by class loader. There are three built-in class loader in Java. What are those? Bootstrap class loader, extension class loader, and system or application class loader. So you can read this. What is Bootstrap class loader? This is the first class loader which is super class of extension class loader. It load the rt.jar file which contain all class files of Java standard edition like java.lang file or package, java.net package or java.util package, java.io package, classes, java.sql package, etc. That means the bootstrap class loader, it is used to high level, whatever the high level standard edition packages are there. The working of bootstrap class loader is to load all that class like java.lang, java.packages, java.utils. This is work of bootstrap class loader. Then extension class loader, this is child class of bootstrap class loader and parent class of system class loader. Means if you try to hierarchy, the system class is the child class of extension and extension class is the child class of bootstrap class. Extension class loader, it's load the jar file located inside java home slash jre slash live slash extension directory. Means whatever the classes or jar file are stored in extension directory, that all files loaded by extension class loader. So this is the use of extension class loader. Then third is system and application class loader. This is child class of extension class loader. It load the class file from class path. By default, class path is set to be current directory. So you can change class path using slash cp or slash class path to switch. It is also known as application class loader. Means whatever the file we have in class path, that file need to load with the help of system or application class loader. So these are the different type of class loader we have in Java. First one is bootstrap, second one is extension, and third one is a system. So bootstrap is the parent of extension and extension is the parent of system. Okay, let's check next question. Question number 15. In Java, what are different between heap and memory stack memory? So most IMP question as a fresher level. So what is different between heap memory and stack memory? So I have divided heap memory and stack memory on the appearance, on their functionality. So first point is memory point of view. So memory point of view, stack memory is used only by one thread execution. Means if one thread is created, that stack will be used for that one thread only. But in heap, all part of application use heap memory. Second, access. Other thread can't access stack memory. Means if a stack memory assigned to thread 1, thread 2 cannot access the stack memory for that thread 2. Here, objects stored in heap are globally accessible. Heap will be globally accessible. It is all part of application use heap memory. Memory management. Stack follow the LIFO manner of pre-memory. Last in, first out. Means how memory management happen in stack. So last in, first out. Means those student enter in the class last, which will be out the first in the outside the class. So like let's take a rack. If we store book one by one as a stack wise, so whatever the book we will keep on the top, it will be first out. So the memory management will be happen in LIFO manner. In heap memory, memory management for heap stream for the generation associated with each object. Okay. Lifetime stack exists until end of execution of thread. Means if thread 1 is executed, then our stack memory will be vanish. But heap memory live from the start till end of application execution. And uses of stack memory only contain local primitive and reference variable to object in heap spaces. Whenever regard with uses of heap memory, you create an object, it will be stored always in heap memory. Whatever the object you will created, it will be always stored in heap memory. Means when we are creating object with new keyword, it will be stored in heap memory. So next question is, what is wrapper class in Java? So as yesterday we saw one question, why Java is not 100% object oriented language. So because of wrapper class also, Java is not 100% wrapper. Every primitive data type has class dedicated to it. Means we have 8 primitive data type. That 8 primitive data type has separate classes. Means int, like I will written here, int having class integer, then float having class float. Float will be start with capital. So integer, it is a wrapper class for integer data, primitive data type, and float is a wrapper class for float primitive data type. So we call them wrapper class because they wrap the primitive data type into object for that class. Wrapper class convert Java primitive into reference type object. This is called as wrapper class. So question number 17. So it's really asked question, what is mean by auto boxing and unboxing? So autoboxing represents the Java compiler that automatically transfer primitive data type into object equivalent or wrapper types to case easy compilation. Autoboxing represents the Java compiler that automatically transfer primitive data type into object equivalent wrapper class to easy compilation. Means if there is an integer, it automatic int data type, it will be automatically transferred to integer wrapper class in autoboxing. Unboxing, It is automatic transformation of wrapper type into their primitive equivalent, means vice versa. If their integer wrapper class will automatically transfer into integer primitive data type in unboxing. So these are the auto boxing and unboxing example.